Hello everyone, and this is a series of tutorials on how to create this lightning strike effect. Okay, so if we look at the final result, this is what we're going to end up creating. Okay, so this will be about 5 videos covering the basic lightning strike effect, and then the final lesson will be on rendering. So the lightning strike is made up of like multiple parts. Okay, so we have the core lightning. Okay, let me just hide everything so that we can see it one by one. Okay, so there's the core lightning. Okay, and then there are particles emitting from the lightning and the ground, and then also like there's like debris particles emitting from the rigid body. Okay, then you have sparks emitting, which are based on the particles. Then you have the rigid body, which is the ground breaking when the lightning hits the ground. And then finally there's smoke. Okay, so those are like the 5 things that we will be looking at. And then lastly, we'll take a look at how to render it. So we won't go through passes and stuff, but I'll just show you, the basic settings that you'll need to follow in order to render it. I'll be rendering it in Octane, but the rules are fairly generic or simple or like similar enough that you should be able to follow it in any render engine of your preference. Okay, so let's get started. In this lesson, I'll create the basic lightning. So I have a new Houdini file and I'll create a geometry. I'll call it lightning. And now usually I create lightning using like a line, so you take a line and you give it some noise and animate it. But I decided to follow a slightly different technique because that sort of helped me create all the various other aspects as well. Okay, so what we'll do is we're going to do lightning based on particles. So I'm going to take a single point from which we're going to emit it. So I'll take an add node. I'll create like 1 point and I'll keep it to around 0.8 in height. So somewhere over there. Okay, the next thing is I want like some downward facing velocity on this. So just take a point velocity node and I will set it to set to value and we'll make it around -2. So what will happen is when we emit particles from these, they will, have an existing velocity of -2 in the y-axis. Okay, that's pretty much it. Okay, so now I can take a pop network and I'll just plug it in. I'll call it base emission. And the first thing is I want to set this to points. So if you press play, you'll see like, you have particles going downwards. Okay, so the second thing we want to do is I'll come into birth. I don't want constant activation. We just want a few particles, right? So what I'm going to do is I'm going to keep this to impulse. I'll do $FF less than 4, so which means the emission will stop after 4 frames. And I'll keep the impulse count to 1. So what will happen is I'll get about like 3 particles. Okay, that's pretty much it. Okay, that's good enough. Okay, now I also want to give it a little bit of randomization. So I'll come to the attributes tab and change the initial velocity to add to inherited velocity. I don't want anything in the y-axis because otherwise it will try to like, go upwards. X and Z, I'll keep it around 0.8. Let's do 0.8 and 0.7. So what will happen is you'll get like, see a little bit of variation like that. Okay, so this is fine. Now, what I'd also like to do is, let's say we wanted to hit here somewhere. So I'm going to take a pop attract. Okay, and I'll keep this to like a value of 8 or 9. So what will happen is, see, they'll all sort of like, more or less try to come here. Okay, let's keep it higher. Let's keep it around 15. What I wanted to move fast enough. So I wanted to hit the ground by around like frame 6 or 7, which is about, if you're calculating 24 FPS, that's like 1/4 of a second, which is fast enough. So this is good. I don't want anything too fancy. But now what we want is we wanted to hit the ground. So take a ground plane and I'll just take a merge. So you don't need to take a static solver. If you just take a ground plane, it'll just automatically collide. Okay, and drop it in. And I'll turn off display proxy geometry. So like otherwise you get to see it. I don't want to see it. So if you press play, you should get this. Okay, turn on real time. So there you go. Okay, now it's bouncing way too much. I don't want it to bounce that much. So lower the bounce amount. Yeah, like come to physical, lower the bounce and lower the bounce forward, which should give you, that's like okay. Okay, and then the last thing is I want to lower the lifespan to around 1.5 seconds, like which is the life expectancy is generally in seconds. Okay, so you'll get this and then it'll just disappear. So by around frame 30, it should be gone. Okay, now another thing I want to do is what we're going to do is we're going to emit all the various things from different particle networks. Like rather than doing like a pop replicate in here and then doing all the emission here, what I generally like doing is, just break it up into different pop networks so that it's just, instead of having like one large complex pop network, you have like, simpler, smaller ones, spread out. The only thing we want is, we want a group when it hits the ground. So come into the pop solver and there is a collision behavior and just click on move to hit, and we'll also turn on add impact data. So what will happen, sorry, don't do move to hit, turn on collide group and also do like color hits, and we'll just call it hit. So what will happen is when it hits the ground, see, now it's turning red, which is good. That's what we want. So we'll be able to use this group for like, sparks emission and stuff like that. Okay, but that won't be in this lesson. That will be later. Okay, so this is fine. Like, that's all that we want. Okay, now when you come up, it will keep the ground plane. Okay, so what you need to do is we need to get rid of the ground plane. So I can probably just, yeah, this is fine. We'll just keep, this becomes the name of your group, like source first input. So if you want to change that, you can change that. But what I can do is I can just take a blast here after the pop network, and we will set this to points and keep it to source first input and delete non-selected. So you will have just the particles. Now comes the big question, which is how do I convert this into lightning? What we're going to do is we're just going to take a for each. Okay, I'll call it a for each point, and let's shorten the name or something. And what we'll do is we're going to take this original point. We're going to use an add. We will merge the particle and this point, and we are going to connect them. So just do by group. And what this will do is it will give me lines. See. So you get, this, which is pretty decent. Okay. So now the next step is just converting it into lightning. Okay. So what you'll do is, after the add, we will take a resample. Okay. Yeah, this is a fine enough place. So take a resample. I'm going to add some points to this. So I'm going to add noise at 2 levels. Okay, like one is for a general shape, and then we'll add a finer frequency noise for like more detail. Okay, so this is good. About like those many points are fine. Now the next thing is I want to add some noise to it, but the noise is going to take like it won't know how to fit to it. So what we'll do is we'll give it some normals. Okay, so I'm going to take an orientation along curve, but the problem is because this thing sort of moves around, like the noise or the normals don't remain steady. Okay, so what you want to do is take the tangent type and change it to z-axis. So it will be like, much more fixed. And what I can also do is I can come into additional rotation, and we can just try to sort of, like give a little bit of a spin. So you'll see the advantage of this when it happens. Okay, so I'll come here, and now let's take an attribute noise vector and set the vector to position. See, so this is what happens. But what we want is we want the first point and the last point to remain fixed. So what we'll do is we're going to take the resample and we're going to calculate a curve view, and then I'm going to store that into a float attribute. Okay, so take a float. So take attribute as just float, and we'll call this as mask. And what we're going to do is we'll keep it to set always, and we'll keep this to remap attribute. Okay, and the attribute we want to remap is curve view. Okay, now let's just first of all see if it's working or not. So come in here to the attribute noise vector, turn on blend, set it to use, see if I take the blend and make it 0, see, so it basically does that. Set it to use attribute, which is mask, and there you go. Okay, so what is happening is you'll see that, like that point does not move. The top moves, but the bottom doesn't. So we need to readjust this. Okay, this mask, I'm going to take this, and these two are going to be steady, and just the middle part is going to move, like that. Okay, but this is looking terrible. So what we need to do is we need to take the attribute noise and set it to noise along vector, which is why we added the normals. Okay, because otherwise there's no vector for it to set it to. So just turn on noise along vector, and there you go. So now you'll see like it does this. Okay, so just to show you why we change the orient along attribute to z axis is because if I set it to whatever is the normal, which is the average of edge dis, you'll see like it sort of flips because it's actually a particle. So there's like random velocity in there. So the normals keep sort of flipping. Okay, so which is why taking a z axis and ignoring it altogether is generally a good idea. Okay, so there you go. So this is fine. Now what you want to do is we'll do a couple of things. First of all, I can lower the element size a little, which is fine. Okay, secondly, let's come into the offset, and I wanted to move downwards, so it feels like the lightning is flowing downwards. So take the Y offset, and so we can just make it move downwards like that. So I'll just do a minus at time. Let's try divided by 2. And what that should do is, see, you'll get this happening. Okay. Which is fine, like it looks okay. Maybe lower the amplitude a little. Yeah, okay. Okay, the next thing is they all currently have the same noise. Okay, so what we want is I want like each curve to get a different offset value. Okay, so we just want to take the offset like to be different for each one. So what we're going to do is come to the for each node and say create meta import node. And this allows you to, like, once you create this, you get access to certain attributes, and you can use those to sort of modify or randomize anything in here. So what we're going to do is we're going to use the iteration value. And what we're saying is for each point or each iteration, use that value for the noise offset. So the way it works is come into the attribute noise vector and take the offset value and type in detail. So it's the detail, because if you will see here, like let me just come in here, you'll see it says detail attribute. Okay, so that's why we need to type in detail. Okay, so come in here and now we have an error, which is fine. So take detail, and what we need is we need like 3 things. Okay, so we need the name of the node that will get the value from. Then we need the attribute name, which will be called iteration, and then the index value, which will be 0. Okay, so take / meta. We called iteration iteration and 0. And see, there you go. So what we have is we have a different noise for each one. And if you want, we can probably make it go faster. Let's see how that works. Yeah, and you can also try to turn on animate noise, see if this helps. Yeah, this is fine, see. So not, but as I said, the advantage of this is like, in generally when something like this is hitting the ground, then the question comes up like, how do we emit particles from here? So then it's like you create a SOP and then you put this into a group and do all of that stuff. Because these are particles and we have our base particles here, you can use those to emit anything else that you want from there. See, this is nice. So what you can do is you can actually like use this vector to sort of rotate the noise around, and I can also give a little bit of a spin so it can do, so you can try to do more things with this if you want to do that. Yeah, okay, that actually doesn't look too bad. Let me just lower this down to around like 100 frames or something. Okay, I think this is fine. Okay, so this is like, one set of noise to it. Now we want to do the same thing again. So I'm just going to take all of this and do a Control C, Control V. Okay, this comes in here. Yeah, let me just bring this back. And what I want to do is I want to firstly resample this a bit more. So I'll get like, more value here. And then we repeat the same thing. Okay, we want like a noise map or we need a mask here. And then this is all fine. So now what we do is I kind of like, I'll lower the element size. I'll also lower the intensity a little bit. And what we should get is, like a little more detail on the whole thing. Maybe I can offset this a bit more. So let's do like +5. Let's make this a little faster. Yeah, okay. This is fine, I guess. Yeah, there you go. Okay, I turned off apply, roll and twist in the second one, but there you go. See, this looks nice. Okay, so this gives me, the basic that I want. Okay, the next thing I want to do is I want like an additional set of sort of lightning flowing around the core lightning. So if I look at my original file, see, you'll see that, like this has additional sort of lightning flowing around it like that. Okay, so the way we'll do it is actually pretty simple. Okay, so I'm going to take this and I'm going to do a sweep. And I'm going to set it to round tube. Okay, but let's delete a few attributes because it's like, it's using probably the velocity, or we also have normals on it. So let's do one thing. Let's just do like a star and get rid of everything. So there you go. Okay, now the first thing we want is, let's do one thing. Let's try to keep the, no, let's not keep anything. Okay, so this is fine. Now what we do is, I'm going to lower this and I'll do apply scale to curve. And I'll keep it in thick in the middle, and then bottom and top is like thin, like that. But I don't want solid geometry. So what we'll do is we'll change the surface type to columns. So we just have like lines like these. Okay. But before that, I'll just show you what I'm going to do. Okay. So it's easier to see it with quadrilaterals. What we'll do is I'm going to do it like, give it some twist. So it's sort of like it's flowing around it like that. Okay. And now I'll come in here and I set it to columns. And what we'll do is I'll take a delete, and this is 8 columns, right? So I'll just take a delete here and we'll say delete by range, 1 of every 8, delete non-selected. So you have 1 left. Okay. Like if I want, I can do a resample here and give it some more points so that it kind of, see, there you go. So what's happening is, if you look at this, see, there's like our main lightning, and you have this thing which sort of flows around it like that. And so what I can do is I can take this guy and I'm going to set it into a group of its own, and I'll call it, let's call it thin. So we'll merge these two together. Okay, so I'll just take a merge here. So the original line, which is this, actually, no, let's keep the, see, so we have like, two of these. And if you bring it out, see, there you go. So maybe I can lower the resample a bit. Yeah. Yeah, okay, so this is fine. Okay, so now as a final thing, let's just give it some thickness. Okay, so firstly I'll take a blast here after the for each, and I can just get rid of the thin. Okay, so we have like, let's call this thin, and to Control C, Control V, and let's call this, this is the main. Okay, so we'll call this main. You can also try to use a split, like even that should work. Like let's just take a split here and we'll take the group as thin. And if I do a null, see, you'll get like, the core lines and then the, so the core lines and this. So same thing, instead of taking two blasts, we can use a split. Okay, so what I'll do is I'll just take a sweep here again and set it to round tube. Again, do the same stuff. So take an attribute delete. Do I have the curve view on this? Yeah, I have the curve view. Okay, so what we'll do is I'll do a star, but I'll just keep the curve view. So I'll do a uptick like that and say, and type in curve view. So it will delete everything except the curve view. And then I'll take a float, and by default it sets to p scale, which is good. We just want to set it to p scale. Do set always keep it to remap attribute, and we'll remap curve view. So you'll get this. Okay. And let's just, we'll keep it thin like that and thick in the middle. Let's keep it big, because I can just come into the sweep and adjust that. See, so we'll get this. The reason I'm giving it like geometry or like thickness is because we'll also use this later on to, hit our rigid body. So it will be easier, that there is actual geometry there. Okay, so this is fine. And then I can also take a color and we can color it. So this can be set to curve view. There you go. And what we'll do is I'll set this to maybe like a bright blue or something. So let's keep it around 5. And this, I'll just set it to like a dark blue. Okay, so this forms the core, lines that we want. Let's just set the background to dark. Okay, and I'll set it to like flat shaded. So, it just looks nice. And then I'm going to repeat the same thing for this, except I'm going to make some small changes to it. So let's do Control C, Control V. And okay, I don't think it has curve. So do one thing, take a resample and we'll like lower the point number. I'm going to turn on curve view. So this will give me, this thing. But what I want to do is I don't want it to be visible, like everywhere. Like if we merge this, it will just look weird. It'll look like this. I don't want that. So what I want is I want it to be visible in parts. So what I can do here is after this p scale, like first of all, let's just lower this further. So it's like really thin. Take another float, attribute just float after this p scale. Set it to multiply, and we can set it to noise. See, so what will happen is come to the remap and we can do this. And there you go. So what will happen is you'll get like, pieces of it. Let's keep it to 0.05. See. So you can have like pieces that disappear, and we'll turn on animate. So see, it's not visible, all the way through. So you'll get it like that. Okay. It looks fast now, but it's fine. I mean, it's supposed to be lightning. So there you go. See, so what you'll get is you'll have like this sort of flowing around it like that. Okay, as a final thing, what I can also do is, if you feel like it's fast, you can just, there are a couple of things you can do. Like you can lower the point velocity here, and we can also lower the pop attract in here. Like if I make this around 5, so then it won't, like it'll slow down. See? And we can also sort of like lower the noise speed in here. Like with the attribute adjust, the attribute noise vector. Okay, like I can take this, and maybe I can make it 2, so it sort of slows down. Yeah. Now, as a final thing, what I can also do is I can take in a point node, and we can give both of these a little bit of an alpha. Okay, so this one I can just keep it to alpha and do set value. Yeah, so just do constant value and keep it like a little bit. Yeah, like just keep it, like really faded out. And then this one, it has curve view. Yeah, okay. So what I can do is I can just take this and I can do a ramp. So do ch ramp and we'll call it fade. It'll be set to at curve view. And create it. There you go. Okay, so it's like faded off towards the top. Yeah, so see, there you go. So now the outer lines will be like, just like a flicker. All right, so that's pretty much it for this lesson. So this is the basic lightning setup. Okay, so the next lesson, we're going to take a look at how to do like spark emission from the ground, and then also some particle emission from the main lightning. Okay, so that will be lesson number 2.